is a recording of the 3.9 practice. This is a lot more of the proofs that we saw, or the theorems that we saw on Friday for 3.8. This is kind of applying those proofs, so we want to make sure we understand how to do them all. So I would highly recommend you try them first as best you can with your yellow sheet like this. Look for keywords, like if I see that perpendicular, I know I'm looking for that on my list here, and kind of see how well you can get through these. And then once you've actually tried, maybe feel free to pause this and then play it when you're ready to see the answers and to check them. Of course, Canvas also has the answer key posted if you just want to check the answer key just to see if you did it right. But here's how we would start. We're going to start with our given, like we always do, and we write out angle 2 is congruent to angle 3, and line P is perpendicular to line T, and line M is perpendicular to line T as well. Looking at the diagram there, we see those two lines, and they're perpendicular to this one. So when something's perpendicular, then we know we can go from there. The only mention of perpendicular on this sheet here is right here, where we have this and its converse. So we're going to start with if perpendicular, then right angles. And we have two of them. So if perpendicular, then right angles. And let's write down which ones we have. Now you can technically write this over 2 steps if we want to, because we are going to apply it to each one of these. First one, for P is perpendicular to T, we could write one, and then we can write another one, or you can combine them. So if P is perpendicular to T, we get that angle 1 is a right angle, right? It would be like a right angle right here. We didn't know that from the beginning, but now we know that that's there. Same with line M being perpendicular to T, we'd get angle 2 as well. So I'll just write them both on the same line. Angle 1 and angle 2 are right angles. You don't use the little m's for measure, because we're not saying that their measurement is 90 degrees. We're just saying that we're identifying them, classifying them as right angles. Now we have to figure out where to go next. Because I brought in the word right angles, I come over to the sheet and I look for the word right angle. Here it is. There's one spot that says that's 90 degrees, but let's make sure we don't miss any others. Remember, this other one said it's perpendicular. We don't want to do that one because that would literally be going backwards to where we came from. We don't want to say it's perpendicular. And then remember, we just learned about one of them on Friday. If right angles, then angles are congruent. So I have this one and I have this 90-degree one, and I have to decide which one do I want to go with. Well, you look at your proof to help you decide. Because the proof has congruence for the final answer, and this given even had a congruent to it, nowhere does it mention equals. I want to say the one on the back page, if right angles, then angles congruent. Okay, so I want to say angle 1 is congruent to angle 2. These two here were right angles, and now I know they're congruent because of this new theorem that we just learned about on Friday for 3.8. And now we're ready to finish this up for step 4, because now what we see here is from step 1, or from our given, we never use this congruent statement. Angle 2 is congruent to angle 3, and now we had the original one. So to help me get to step 4, if you need some like scratch work off to the side, you can do it either somewhere else, or if you're gonna do it on this step, please use parentheses to say, okay, angle 2 was congruent to angle 3, and angle 1 was congruent to angle 2 from the previous step. Using both of those, this is not part of the proof. This is just like my thought process, or what my thinking is for this, and then feel free to use either highlighters or colored pens if you need to say, okay, those are both angle 2s. When that happens with transitive property, I know these two are congruent to each other. The other two. So this would be angle 1 is congruent to angle 3 by transitive prop congruence. Now you could have taken 5 steps instead if you instead chose to say if perpendicular then right angle and did it twice for each one of these lines. You could have also made this a much longer proof if you chose instead to go to 90 degrees. So if you tried to show that the measure of these angles were both 90 degrees, then you use substitution to set them equal to each other, then convert back to congruence, you would have like an extra 3 steps, so you'd probably use up more of these lines. And that would be okay. It's just this is the quickest way, easiest way to get there. Okay, so let's keep going. Here's the next one. On the next page, There's one at the top here that says angle 1 is congruent to angle 2. I'm going to mark that in my diagram here with the congruent symbols. And we know that ray EG bisects angle DEF. This is hard to see here, but this is an F here. And so if that's the case, I know that 2 and 3 are going to get bisected or become congruent because they've been bisected. So that's kind of like where I'm headed. I'll have my given, and I'll write down the entire given. Angle 1 is congruent to angle 2, and ray EG bisects angle DEF. Okay, and then so for step 2 here, I'm going to use the definition of bisects because I can't really do anything else. Now, some people might say for step 2 instead, could I convert this to equals? Absolutely, you could. You could say if angles congruent, then angles are equal in measure instead. For step 2, I'll do that eventually, but let me just go ahead and start with bisects since I noticed it's there. And remember, be careful which one. I'm not taking the segment as bisected. I need the angle as bisected because that's what's happening here. So if angle bisected, then angle divides into 2 congruent angles. Okay, and then I can write down which 2 angles I'm talking about. That's 2 and 3. Angle 2 is congruent to angle 3. Now the reason I waited to try to convert this to equals, because I know that at the end I have to end up with an equal sign, but I waited to do that is because I actually have to do a transitive property here now. If I did that transitive, or if I tried to do that second step as if angles congruent then angles equal in measure, I'd have to do it again then to convert this guy. So it's easier to wait till you're ready. And on this one, I would do transitive now. I can't do substitution property because that one does not work for congruence. These are all congruent. So again, if you want to use substitution, or transitive property, feel free to use highlighters. These are the same. I want to get the other 2. Okay, so 1 and 3 would end up being congruent because of the transitive property. All right, and then we're on to step 4, where now we know 1 and 3 are congruent. I want them to be equal, though, because notice I'm going to eventually need to solve this equation. So I want them to convert now from congruence to equal. So if angles congruent, then angles equal in measure. Measure of angle 1 is equal to the measure of angle 3. And finally, I can use substitution property and start solving until I get an answer. So I'm going to plug in now the rest of this. Actually, I forgot to write it in my given. Measure of angle 1 was 4x, and measure of angle 3 is 2x plus 30. Now, the degree measures are included with those. You could technically write them in because that's how it is written there. But when you go to plug them into your equation, you don't need to keep parentheses or your degree symbols there because we're just getting an answer for x. So 4x equals 2x plus 30. And now we're solving using the addition property equality. So if you do need to show your work for that, you subtract 2x. 2x equals 30. And our last step is the multiplication property equality, where you would divide by 2, or it's the same as multiplying by half, and that we get x is 15. So kind of a longer proof, but we already kind of knew how to do the bottom half of the proof because that was from the first quiz. So really only the top part is like the new stuff with the transitive property and applying and then going to equal sign. All right, and finally the last one, it can be done pretty quickly if you use the new theorem that we saw about supplements, but we'll kind of bring that in just a second. So this says angle 1 and 2 are supplements, and angles 1 and 4 are also supplements. That was just in the given. And measure of angle 2 is 45 degrees. So we're starting off with my given, writing out all that stuff. Angle 1 and 2, supplements. Angle 1 and 4, supplements. And measure of angle 2 equals 45 degrees. Okay, so we're going to start off with this new theorem that we just learned on Friday. Oops, sorry. Where we say if 2 angles supplementary to the same angle that they are both supplementary to. So 2 and 4 are both supplementary to 1. That's the same angle. Then angles are congruent. So we can say angle 2 is congruent to angle 4 because they were both supplementary to the same exact angle, angle 1. And then we would keep going. So now that I want to bring in angle 2 and 4, I would say if angles equal or congruent, then angles equal in measure, because now I want to bring in equal signs. Measure of angle 2 equals the measure of angle 4. And at this point, I do need to also bring in the angle measure. Now, the problem here is I don't know, I know that measure of angle, actually, I'm sorry, I can substitute in this 45-degree angle in for measure of angle 2 at this point. So wrote it in the wrong spot. Substitution, prop, equality, and substituting this right here, this 45, right in for that measure of angle 2. So 45 equals measure of angle 4, or 45 degrees even. And finally, I don't want the answer written this way. I'm going to switch it around. So symmetric, prop of equality. Because I needed to say measure of angle 4 is 45 degrees. Okay, so that can be done in 5 steps if you just use that new theorem where we were able to just go right to the 2 angles that are congruent. Okay, and that's pretty much it for this practice. If you need some more practice aside of this, make sure you're trying the review packet, and also there was a 3.9 homework even that has some more proofs on it that you could try out for some additional practice.